Is it going? Simplifying and rationalizing radicals. Part 64.
I think it's part 2, buddy.
I think it's page.
Page 64, part 2.
Page 64.
State.
Good news and bad news. The good news is this is something you saw last year, so you will notice there is only one side to yours. We are going to breeze right through it, and then we are going to the Pythagorean theorem. That's the bad news, is we do have something after this. The extra good news is that the Pythagorean theorem tends to be everybody's favorite because it's straightforward, it's the same every time. Okay, so let's go through this. The first thing I expect you to do is to go right here, directly in front of you, folks. You'll see these lines. I want you to put the perfect squares from 1 to 15 right there. I can't talk like that anymore because it really hurts my neck muscles.
Boy, there's some big old muscles.
Right here, folks. Right here.
Right here. You ought to hear my husband make a funny voice like that because it makes me laugh every time. We can be in the middle of a knockdown, drag out fight, and if he cuts to that chipmunk voice, I lose it. So I'm like, okay, you win. Sorry. You're really funny.
That's how you know.
That is my challenge for you. If you're ever in an argument, try to make cartoon voices. I promise your argument will settle down. Because you're going to be arguing like this.
Arguing like this.
Arguing. I like that.
Right here.
All right. We got 1, 4, 9,
No,
16.
That's not how you do it, Cody.
Stay in your lane. You stay in your lane. You stay in your lane.
8.
I wonder where they learned that from.
9. I know.
Don't call me that.
I need a shirt. I need to print shirts and trademark it. 11, 12, 13. Ooh.
169.
Yep. 169.
196.
There you go. Okay. If you forget how to generate the list of perfect squares, which you shouldn't because we've already done it 3 times now, you're going to come underneath this. If you need to remember how to do this, put recall. This is just 1 squared. This is 2 squared. This is 3 squared, and so on. Okay. 2 vocab words. Very important. You will hear these a lot in your higher level math classes, especially.
I'll tell you if you want.
Yep, I'm not. Radical. Nope. Radical means the whole thing. If I say, look at that radical, I'm talking about you looking at the entire square root of some crap. Now, how are you going to remember radical? It's the whole thing. This is going to sound really stupid, but it works. Hold on. How did that change to blue?
Radical.
Yeah, it's. I told you it's stupid, but it works.
Radical.
Think of whole. Like radical, whole means the whole thing. It might work. All right, the other vocab word that you will hear a lot, and if you have a highlighter, it would be really helpful. It means, or it's the word radicand. You're going to hear that word. Yes. I'm going to highlight that. I'm going to highlight. I'm going to highlight that, and then I'm going to highlight that word because the radicand is the piece of underneath the square root symbol, okay? I want you to write right here that it's what's underneath. Notice it is not the square root itself. So the radicand is the pretty one. The radical is the whole thing, okay? I want you to think of, y'all know me, I always relate back to food. I want you to think of canned food. You have canned food. What's the only part you're interested in?
The can.
The food on the inside of
Not
the
the
can,
can.
right? So radican, the D on the end is silent. It is not radicand. And we're not saying radidon't. It is radican. Last week. I want you to think of canned food. The radican would be the stuff up underneath the square root only. You with me? Yes? Okay. Let's dive right into what you already know. You should be able to do 1 through 4 right now. You are breaking down these radicans, these radicals. If the radican is perfect, then you are simply taking the square root of it. What is the square root of 49? 7. Right? Now, how do you type this in your calculator? Hit the second button. Then hit down the left side. Do you see the button that says x squared? Look above it in blue. Do you notice that it's the square root symbol? So push that and then type 49 and hit enter and it'll say 7. Did you get it? Alright, finish the remaining ones.
Mm-hmm. I am not in the next class. You want me to put that in this?
Yeah. What's the square root of 36?
6.
What's the square root of 100? What's the square root of 1?
1.
Square root of 1 bothers people sometimes, but the square root of 1 is 1. Because 1 times 1 is 1. The square root of 0 is 0. Yeah. Okay. If you have a highlighter, I hope you're highlighting it because I've given you a section of each type of question. This was when they were perfect, right? This is when the number underneath the radican was perfect. Okay, here's when it's not perfect. Then you will need to find the largest perfect square that will divide into it nicely without a remainder, which means no decimals. So we did this in the warm-up. So do the square root of 40 right now.
4 and 10. Dude, why did...
Try to allow some time for everyone to try it, because if they just hear the answer, then they aren't going to try it. So allow some time for everyone to try before we say the answer. Where did you put those papers that I was sending? Thank you. Just set it on my desk. I'll take it home. Harvey, this is when we were out. It was some page you missed. We covered the front of it. Okay, what perfect square did you find goes into 40?
I think it's 4.
And how many times?
10.
So you're rewriting this radican as the product of 4 times 10. Always put your perfect square first. I'm going to put PS
Yes.
for your, I'm going to come over here and show you. PS stands for perfect square. Always put it first because it'll keep going. What is the square root of 4? 2. And then now your answer is going to be 2 square root 10. Now go to 192. Now that's a number you're not comfortable with, I'm sure. Find where 192 falls on your list of perfect squares, right here, and then start dividing by working your way down. So you're going to go to your calculator and you're going to divide 192 divided by 169. A decimal means keep going, not the right answer. So 192 divided by 144.
No.
And keep going and going until you hit one that's pretty. Don't say it. Don't call it out. Keep dividing. Caleb, make sure you're trying.
I already did.
Oh, okay. Good. 64 goes how many times?
3.
3 times. Write your perfect square first because it's going to keep going and then it's going to come out of the square root. When you take the square root of a perfect square, you no longer write the square root symbol and you want that number in the front. So this would be 8. Bring that down. So that's the answer.
What?
What?
Well, I got
16. I got 16 square root.
I got 64 radical 3. I got that. What?
Is 64 times 3 192? Yes? Okay. And what is the square root of 64?
I didn't know it was that short.
Well, I just simplified it all the way down.
Yeah, me too.
And I got 16 square root 3.
Oh! Really? Did you go the long way?
Oh, it don't work.
That's the only way we've ever known.
Enter
Geometry!
Miss Holcombe. If you'll learn my way, for every one of them, if you learn my way, you'll be done in 2 steps. Every time. Doesn't matter what the number is.
Whoa.
Every single time.
If you learn my way, I will make you pay.
Okay. That's enough for today.
Yeah, I agree.
And that's all I'll say. I'm done.
Yeah, I thought that was
I killed it. I know, I killed it.
I
Do you see it though, y'all? He divided and divided until he got, I say he because I asked him and he volunteered it for me. Hold on. He divided until he saw that 64 works.
Well, I know that.
And so the square root of 64 is 8. Bam, you're done.
I should know that.
So embrace that one.
Oh, this is easy.
Make sure you let them know. Hold on. If there's a number in front of the radical, we already did this with the last example that was in the warm-up. Come right here, highlight if there is a number in front of the radical. Then you just simplify the radicand, and at the very end you'll multiply the number in front by what comes out. So like right here, we have 4 times square root 8. This is what you need to break down. What perfect square goes into 8? How many times?
2.
Notice because it was under the radical, I'm still writing under the radical, right? I haven't square rooted anything. Now this just comes down. It just comes down.
Oh, wow.
Then what's the square root of 4?
2.
Okay, and then this comes down.
So 8 radical 2.
Now, okay, that was my question. If you just write it like that, doesn't it look like 40? 42,
Yeah.
and that's not it. There's an understood multiplication right here. Okay? So this is 8 square root 2. Okay. No. No, if you don't mind, because I'm trying to get to Pythagorean here. We're breezing through. Number 8. Shouldn't have to think too hard on what goes into 125. Think of money. Think of quarters. 25 will go how many times? 5 times. So this just comes down. Put the dot there to remind yourself it's going to multiply. This splits into square root 25 times square root 5. What's the square root of 25? 5. Now you can leave it here or you can bring it down to see the multiplication of it. It's up to you. Negative 15 root 5.
I'm good at this.
You're going to need to be. All right. If there is a radical in the denominator of a fraction, then you do what is called rationalize. Y'all know in math you're not allowed to divide by what?
0.
Okay. Not allowed to divide by 0. In math, you're not allowed to have a square root in the bottom of a fraction. It's like against the law. Okay, how do I get rid of this square root in the bottom of the fraction without changing it? First of all, no, do you see an equal sign? See, that's the difference. We don't have an equation here where whatever you do to one side, you do to the other. We don't have an equation. This is called an expression, meaning you're just looking at one chunk. Does that make sense? So the rules change. Let me pull a calculator up so you can see this. All right, when you are dealing with just a plain old number, not an equation, just a number, what's the only thing in math you can do to something without changing it? Like you're actually doing something math-wise, but then the answer is the exact same. Close.
Multiply by 1.
Multiply it by 1. What happens when you multiply anything by 1? Nothing changes, right? We're going to multiply this. Now, for this particular problem, I want you to write this. We're going to multiply this by a big old fat fancy 1. You could just put a really big bold 1 if you wanted to. You don't have to put that. Put a big 1. We're going to multiply by 1. Now, you might think to yourself, well, if I multiply that by 1, then I still end up with a radical in the bottom. Yes. Okay, so we have no wiggle room here. Because anything I do to this, I'm changing its value. What's its value? 5 divided square root 3. That's its value. I cannot change that. All right. But I have wiggle room where the 1 is. I can change how the 1 looks. If I multiply this bottom, square root 3, by another square root 3, then I'm going to generate a perfect square. Isn't anything times itself perfect?
Yes.
Y'all staying with me? This is so important. This bleeds into Algebra 2, Pre-Calc, Calc 1, Calc 2, Calc 3, Trig, AM/DM, and college readiness. Y'all staying with me? I'm telling you. I'm going to tweak the 1 to look different. And it's going to get, I'm going to change the 1 based on the problem. The problem is that square root of 3. That's an issue. So I'm going to just bring this down to show my work. I'm going to write my 1 like this. Now, why did I write it like that? Because what is anything divided by itself? 1. Isn't this just a glorified 1? And where did the number come from? It came from the issue. The rule breaker was the square root of 3. So now you have, and I know y'all are not y'all don't like fractions. I need you to embrace fractions as piece over piece. You are multiplying a fraction times another fraction. You just multiply straight across. Don't you dare cross multiply. That's when there's an equal sign in between. We are not doing that here. So multiply straight across. 5 times square root 3 cannot multiply together. It just shoves together like a magnet. You can't actually multiply the 5 into the radical. They're not like terms. Square root 3 times square root 3 is square root of 9. What is the square root of 9? Now, we wrote a lot on this one. We will not have to write as much on the next one. And that's the answer. Yeah. Now, I'm changing to red, which means it's
Wrong.
Look right here. Please don't get excited and see a 3 over a 3 and think, oh, those cancel, the answer is 5. No. Why can those 3's not cancel?
Because it's a radical.
One's under a radical and one's not. Think about it. One's in a can and one's not. They cannot cancel. So you are done. Okay? All right, let's go to another one and try it. Negative 2 over the square root of 5. If I told you to rationalize that, you would multiply it by square root 5 over square root 5. Now multiply straight across. So we got negative 2 square root 5 over, now this is where you can start to cut corners. The bottom will always become perfect. And that's by design. If it doesn't become perfect, you did it wrong. You multiplied by the wrong number or you didn't multiply correctly. Let's make a note. The bottom always becomes perfect. Always. And when we say that, we mean that you can take the square root of it. So right here, square root 5 times square root 5 would be, I'm going to draw an arrow, square root 25, right? What is the square root of 25? 5, that's the answer. Negative 2 square root 5 over 5. Now it's no longer breaking the rule. And I meant to show you the value. Look right here. Go back to the one where I'll type this one in. Negative 2 divides square root 5. Ugly decimal. I'm going to enter that one now. Negative 2 square root 5 over 5. Look at that. Do they hold the same value? Yeah. That means you did it right. Okay? Alright, you try this one. A little tricky. Actually, I'll help you with it. What is breaking the rule?
2.
Everybody look at it. What's breaking the rule?
There's 1 on the bottom.
The rule in math is you cannot have what? Where? Radical in the denominator. So let's make a note. No square root in denominator.
Whoever came up with that killed it. Whoever did. It's terrible. We didn't have math to it.
Okay. So what is the rule breaker right here? Square root 2. We're going to multiply both sides, or top and bottom, by square root 2 over square root 2. Now, I put this here because it's going to happen at some point. When you have a radical times a radical, you can multiply the numbers. So right here, I have 4 square root 7 times square root 2. So that means I'm going to get 4 square root 14.
Yeah, you've done that right. Over 2.
Over, you will notice this always comes back to the radicand. This would end up being the square root of 4, which is 2. Careful. Now, can the 2 divide into the 14? 14.
No.
Can this 2 divide into that 14 to
No.
reduce? No, think about it. That's in a box. It's protected. It can divide into the 4, and you have to. So this 2 would divide into that 4 2 times, carry the root 14, and now you no longer have a fraction at all.
Okay.
See that?
Neat. Luckily we don't have it back.
Well, that's because you're fixing to practice that exact same stuff with Pythagorean theorem.
Oh. Better.
Dude, me and that Douglas, I used to play in Holcombe.
What page was this, Mace?
Yeah. Here you go.
Oh.
Thanks, dog. Something hard.
I don't know why your negativity is going through your head, but this is not hard. You need to get through your head that you can do
Hey,
this.
some people think things are hard. Don't be so.
It's not hatred. I said you can do this. I'm being
Okay, you'll notice this does not have holes punched, and that's because we are going to glue it down, but we're not going to do it today. We're just going to write on it like normal, as is for right now.